we go. Okay, so today is day 25 of Unit 2 in Statistics, guys. We are just about done with this unit. We've already covered all the topics. Now we're just going to make sure we understand every part of it. So, something we learned how to do yesterday was making a box plot. We're going to go over that again step by step. So if you missed that yesterday, you're going to learn it today. One part that we didn't go over specifically, that's a huge part of making a box and whisker plot, is the concept of median. So for your do now today, I went ahead and made some notes, and I wanted you guys to go over these and kind of do a little bit of self-teaching. We're going to go over them together though today. So on your notes, I said, today I want us to explore the concept of median. Can somebody read me this definition underneath that right here with this big arrow?
In statistics, the median is the middle number in a sorted set of numbers.
Perfect. So when we're finding median, we're looking for the number that is in the middle. Now, the big key part here is that it's in a sorted set of numbers. When I say a sorted set of numbers, what do I mean by that?
In order.
Yes, they need to be in order from least to greatest. So if your numbers are not in order, we have to do that first. Now, once our numbers are in order, I gave you a couple of examples. Here's the first example. When I have an odd number of data points in my set of numbers, finding the median is very simple. All we do is start from the outermost numbers and count into the middle. So I would start with 1 and 10, then 2 and 9, 5 and 8, and then 7 is the middle number. So within this first set of data, the median is 7. Not so bad. But what about number 2? Number 2, whenever we start from the outside and count in, I start with 25 and 76, 32 and 63, 48 and 57. There is no number in the middle. Okay? So, what if there's no number in the middle? Have my guy freaking out there. And I guess I was just feeling creative when I made these last night. But this little guy here says, you know, it's really no big deal. Okay, we're just going to find the number that's in between the two middle numbers. So here's what we're going to do. Our two middle numbers were 48 and 57. So we'll follow this arrow over to where I wrote out those two middle numbers. We're finding what's between 48 and 57. And I gave you two different ways to figure this out. The first way is we could add those two numbers together and divide by 2. So 48 plus 57 is 105. When we divide that by 2, we get 52.5. And that would be our median. Now the other way to maybe give you a visual idea of how this gets us the correct answer, I went ahead and drew out a number line. What you could do is write out all the numbers that are in between the two middle numbers. So my middle numbers were 48 and 57. So I wrote all the way from 48, 49, 50, 51, 52, 53, 54, 55, 56, 57. And I just repeated the process from the beginning. I count inwards towards the middle, and I end up landing on 53 and 52. There's no middle number again. So if you land on two numbers beside each other like this, 52 and 53, we just pick the number that is in the middle of those, which would be 52.5. Does that make sense to everybody? Okay, awesome. Any questions about that process? Any questions at all? Because we're about to move on to the questions I asked you where you're going to find the median. Everybody feel okay about that?
Yeah.
Awesome. Okay, so number 1. What did you guys get for the median?
26.
26. Did everybody get that? Good. So let's just go through the process one time. I'm going to cross off those two, these two, cross off another, and oop, 26 is left. So my median is 26 here. All right. Number 2, what did we get for our median? 3. Let's see. Cross off -10 and 23, then 5 and 12, then 0 and 7, then 1 and -2. So we need to figure out what is in between 1 and... Oh my gosh, you guys, yes! I'm wrong!
That's what I did.
Woo! I make mistakes, y'all. Thanks for calling me out. These numbers are not in order. Oh my gosh. I missed the most important step. Okay, let's order our numbers. Okay, so out of all these numbers, which one is the smallest? -10. So I'm going to cross that off and rewrite it to the side. Thank you, guys. Yep, that's where we would get a wrong answer. Okay, so -10. What's my next smallest number? -2. So I'm going to write -2. Yep, then 0, 1, 5, 7, 12, 23. Good. So we're going to get a much different answer than what I just told you guys. We have to put our numbers in order first. Good reminder for everybody. Good reminder for me. I didn't do it. Okay. Now we can find the median. And you guys said you got 3?
Yes.
Okay, let's double check. So I cross off -10 and 23, -2 and 12, 0 and 7, 1 and 5. We need to find the middle number between 1 and 5. So what did you guys do to find the middle number?
Added 5 and 6 and then divided by 2.
Yeah, so you just did 5 plus 1. It's all right. I knew what you meant. 5 plus 1 equals 6.
Oh my God.
Then we take 6 divided by 2, and that gives us 3. Good. You could also write the numbers out on a number line like this. I would have 1, 2, 3, 4, 5. Sorry, it's a little crowded. So then I would cross off my 1 and my 5, my 2 and my 4, and I see that 3 is the middle number there. So for number 2, the median is 3. Everybody get that now? Good, 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 good. Okay. Number 3. Let's make sure these are in order. 26, 47, 457, 542, 682, 937. Are those in order?
Yes.
They are. So we can just start crossing them off. 26 and 937, 47 and 682, 457 and 542. Ooh, this is where it's important to know how to add the numbers together and divide by 2, because making a number line between these two numbers is going to take a long time. That's going to take a while. So, let's do that. 457 plus 542, and all of that divided by 2. Yeah. Let me 457 plus 542. Yep. 999 divided by 2 is 499.5. Y'all get that?
Yes, ma'am.
Good. So that's our median, 499.5 for number 3. Okay, let's look at number 4. Are these in number order?
Yes.
Yes, they are. So we'll just cross them off one by one. 1 and 1026, 2 and 543, 3 and 4. These numbers are already 1 apart from each other, 3 and 4. What is in between 3 and 4? 3.5. That's right, sing it, girl. 3.5. Yeah. All right. How we feel about median? Feel good? Good, good, good. All right.
One question.
Yes, please.
On our test, I didn't really look at it, but are we going to need to circle like you do the middle, or are we able to just put a line?
Let me get our practice quiz pulled up on the board and we can look at that together. Hang on.
Don't think you have.
Yeah.
Just,
Okay. So are you talking about the back page? Right here?
yes. You
So,
want us to circle the in between?
it's okay if you don't, as long as, because where your answers are going to go, so like Q2, this is the median of your data set. So you're going to have it written out here. You're going to have the lower median and the upper median written here. So you can circle it if you want, but if you don't, I'm not going to count it off. Okay. All right, guys. That's our practice with median. Now I want you to go to the second page of notes I gave you, titled Day 25 Continued.
We turn it over, number 2.
Oh, my bad. Just kidding. I swear, y'all. Yes, let's talk about what we're doing today. Sorry, guys. It's been a morning. I'm on.
Together we're gonna get through it.
Whew. Right. It's a Monday feeling Tuesday.
Oh,
Boy, does it have an option.
I know it. Okay, so today we are going to talk about these things. First of all, we are going to review what we did yesterday. We're going to be showing how to make a box and whisker plot. And then that's the end of Unit 2, statistics. That's it. We've done everything there is to do in our unit. So let's review quickly all of our topics that are in Unit 2. The thing that we talked about first on our first day of the second unit was samples. We talked about random samples versus biased samples. So before we move on, let's talk about each of these points that I put for all the topics and make sure we understand them. Down below all these little points and asterisks, I wrote samples and then random and biased. Let's make sure we understand the difference between these two. So guys, first of all, what is a sample? Yeah, it's a way to collect data. So whenever you are at the store and they're giving out free samples of something, it's an opportunity for you to try a small portion of the bigger item that exists. So whenever we take samples of data, we are taking a small portion of data out of a much larger pool of data. So samples are used whenever it's unrealistic to survey every single data point, every single person. So there's two different kinds of samples. We could have a random sample or we could have a biased sample. I want to know what's the difference between those two.
random is everyone, biased is what you.
Yeah, exactly. So whether a sample is random or biased is pretty much based off of the likelihood of each person or each data set being chosen or data point. So in a random sample, I'm going to write every person in the population has an equal chance of being picked. So if it's random, that means there's no way to tell who is more likely to be picked than someone else because they all have the same likeliness. It's an equal chance. So every person in the population has an equal chance of being picked or of being surveyed. Let's say being surveyed. That makes more sense for our example. And I don't know if I spelled surveyed correctly. Somebody can check me on that, but it just looks wrong. I don't know. It's right?
Yeah.
It just doesn't look right for some reason. Okay. Okay, so if a random sample is where every person has an equal chance of being surveyed, what could we write for a biased sample?
Select population.
A select population.
A limited group.
Tell me more. It's a limited group, but what makes it biased? Because you could pick a limited group and it still be random.
Selecting a select few just selecting a select few in situations where it's supposed to be a whole population.
So let's backtrack for a second. Erica, I bet you've got my answer. Sampling in general is whenever we're selecting a few from the population. A sample is whenever we don't collect all the data, we're just collecting some. There's random samples where every person or every piece of data has an equal chance of being picked. The biased sample, in both of these, we're not surveying everyone.
Unequal.
The biased, yeah, there you go. Erica, you had your hand raised. Tell me what you were going to say.
Bias sample generally will have some kind of criteria that links all of the samples.
Yes. So there is an uneven chance for every person to be picked. There's some sort of criteria. So that would be, for example, if our whole population was supposed to include every person in the school and my sample size was just you guys in this room, that would be biased because the other students in history and English and other classes, there's no possible way that they would be in this room when we took the survey. So that is biased. They don't have a chance of being picked. It's just you guys. It's not fair. It's uneven. So I would say,
Not everyone is.
yeah. I'll say some people in the population. Oh my Lord. Quit messing with her. I swear. Some people in the population are more or less likely. I swear, y'all. More or less likely of being surveyed. Likely to be surveyed. We'll say that.
Uneven chance of population of people to be picked.
Yeah, and you guys don't have to put down this exact definition. If you like to explain it in a different way, by all means, that's fine. That is totally fine. Just remember, it's not the fact that we're not surveying everyone that makes it biased. It's the fact that not everyone has the same chance of being picked. Not everyone has the same chance of being picked. Whether it's a random sample or a biased sample, we're not surveying everyone.
Is it like a non-inclusion?
Yeah, non-inclusion. So in this case, if we...
Football team.
Yeah.
Like you were talking the other day, it's like the football team was the only one that was in the group to be.
Right, exactly.
To the other, the word I'm looking for, you know what I'm talking about.
Yes. Okay.
We talked.
Yes.
Yeah.
How do we feel about samples, guys? Any lingering questions about the bias versus random? Or we feel okay about it?
I'm good.
Okay, let's check that off of our list. We went over samples. Next, let's go over correlation versus causation. This is probably our trickiest topic.
I'm good.
Okay, so first of all, do we remember what either of these mean? Michael?
Correlation is when the trends open in the same direction together, and causation is when one directly affects, or that it directly affects the result.
Oh my gosh, you got that perfectly. Correlation is basically whenever one variable moves, the other one moves in a consistent way, whether that's both going up or one going up and one going down. So let's talk about the two different types of correlation.
Negative and positive.
Yes, you're going to be able to see correlation visually. Okay, so that's whenever we have like a scatter plot or something. All right. So this data that I drew first has a positive correlation. As the x value increases, the y value also increases. And I'm going to actually label my x and y. Oh my goodness. Wrong color. So I'll say as x increases, y increases. And what kind of correlation would this second scatter plot have?
Negative.
Negative or inverse. Yes, we could call it either negative correlation or inverse correlation. Very nice, Erica. So inverse, do you guys remember what that word means? Opposite. Opposite. So the words negative, inverse, opposite, those are all very similar in meaning. They all mean that you're doing kind of the opposite thing. So as x goes up in a negative correlation, what happens to the y?
It also
It goes down.
Yes. As our x value gets bigger, our y value is getting smaller. Good. So correlation is only having to do with what we can see the variables doing. It's their behavior. How are they moving and how consistent is it? Causation is less of a mathematical thing and more of a reasoning topic. We need to reason, is this why they're moving in the same way? So one of the examples that we had talked about was, I love bringing this one up because I feel like it's a very obvious not causation. A child's shoe size and their reading ability. As a child's shoe size increases, their reading ability increases. It improves. So those variables are correlated. They're going to go up together at the same time on a graph, but is the shoe size the cause for the increase in reading level? No. So there's no causation there. There's a correlation because they move at the same time, but the causation is not because of the shoe size. Shoe size does not cause your reading level to get better. I'm going to say, does it cause the change? Usually when there's no causation, there's some sort of invisible variable that we have to think about. So in the case with the shoe size and the reading ability, we could say reasonably, as a child gets older, that's what's affecting things here. When a child gets older, they move up in school level, they learn to read more. Also, as a child gets older, their feet tend to grow. So the shoe size isn't making them better readers. There's something that we're not looking at on the graph causing them both to change in the same way. So let's look at an example with causation. I have notes for that. So on, I believe, day 22, I think we talked about this a bunch. It might have been 23. Yeah, it wasn't 22. If you have your notes from day 23, that was last Thursday, go ahead and pull them out, and we're going to look at some of the examples of causation and correlation together. And the examples are going to look like these. Okay, so even if you don't have it pulled up, we're going to go ahead and talk about these together. So we went through these before, but just to review, we just went over the shoe size example. Let's look at plant growth and watering frequency. So somebody did a study on plants, and we're just going to assume that this is a type of plant that watering is beneficial. We can't overwater it. We're just going to keep this simple, okay? So somebody said that plants that are watered more frequently tend to grow taller and healthier, okay? On the graph, we would show that as water increases, the plant growth and health increases, so there's an obvious correlation. Now, to know if it's causation, we just need to ask ourselves, does the amount of water I give the plant directly affect its growth? Yes, it does. If I stop watering my plant, it's eventually going to slow down its growth. It probably will die. So the water does directly affect it. It does directly affect it. Another example of not causation, of like just correlation, was number 4. We talked about ice cream sales and drowning incidents. So somebody noticed that during the summer months, there was an increase in ice cream sales and in drowning incidents. At the same time, they increase and decrease in the same way. So why would this not be causation? Has nothing to do with ice cream. If I buy more ice cream, that doesn't mean that more people are going to drown. That doesn't mean the way to solve the drowning problem is to shut down ice cream shops. It just means that there was something else affecting both in a different way. You know, in the summer months, it's hot. When it's hot, people like ice cream. When it's hot, people like to swim. When you're swimming more, you're more likely to have a drowning incident. Okay? So those are not involving causation. Okay, do we have any questions about the difference between correlation and causation? And we'll look at more when we look at the practice quiz. But if we're okay to move on from that, at least for now, somebody stop me if you're not okay to move on. Okay, let me put these notes up. And we're going to check off correlation versus causation.
I do like it that it turned yellow.
Yeah, it is kind of cool. I don't know why these didn't and that one did. It's so strange.
Well, we need to figure out why.
I know.
I like it.
I'm curious. Yeah.
Okay.
All right, so we can check off correlation versus causation. Now let's look at line of best fit. So this is relating a lot to last unit. Whenever we were graphing linear equations and we were writing linear equations. Okay, remember when we write an equation, what are the 3 steps?
Find M, find B, right?
Yes. Step 1, find your M or your slope. Step 2, find your B or your y-intercept. And then step 3 is just to write the equation. And we'll look more at that in depth whenever we get to the practice quiz. I don't want to spend too much time on it right now because we'll go in a lot more depth in a minute. Okay. We then talked about how to read a bar graph and a histogram. How to read a bar graph and a histogram. You guys remember that? Okay. So again, we're going to go over that in the practice quiz some more because I've got some problems like that on there. If you missed those lessons, I don't think it'll be hard for you to catch up. It's very simple and straightforward. You guys will get it just fine. And then making a box plot, box and whisker plot, that's it. We're going to do that right now. Okay. So now go ahead to page 3 of the notes I gave you, where it says how to make a box and whisker plot. We're going to do this together. Now, these are considered your notes. You can use this on the quiz. I made this guide for you in hopes that it helps clarify the process. which we did a box and whisker plot for our exit ticket yesterday, and most of you did it flawlessly, so I'm not really worried about y'all. But I just thought it would be good to have a little recap. So I am giving you this data set. 10, 15, 35, 7, 12, 41, 6. Step 1 says to put the data values in number order from least to greatest. So let's do that first. All right, we'll do 6. Then what comes next? 7, 10, 12, 15, 35, good, 41. Okay, step 1 is done. Okay, now for step 2, we need to identify the minimum and maximum values of the data set. So for step 2, what I'll have you do is draw lines on either side, and then we're going to circle our minimum and maximum values. What's our minimum? 6. So we'll circle that. What's our maximum? 41. Good. So those are labeled. And if we want, I didn't give you slots to write out your answers, but maybe by each step we could write what we have so we don't lose track. So my minimum was 6 and my maximum was 41. Okay. Now we found our minimum and our maximum. We need to go to step 3, which is to find Q2. Q2 means the second quartile. Okay, that's a big fancy word. It really just means that we're finding the median of the entire data set. So how do we find the median of this data set?
Count both ways.
Yeah, let's count into the middle. So 6 and 41, 7 and 35, 10 and 15. Ah, there it is, 12. So that is Q2, or our median. So besides step 3, if we want to keep track of our numbers again, let's do that. We got 12 for Q2. Okay, now here is where we get a little bit trickier.
So if we're not including the Q2 median from step 3, then it would be 10, it would be 7.
Yes, it would. So let's go through that together. So for step 4, we're finding Q1. The Q1, quartile 1, is going to be the median of the lower half of values in the data set, not including the median we just found, not including Q2. So I like to bring my data values down. I've got 6, 7, 10, and this is where 12 was, so we're going to end it there. Okay, and then there's the rest of my data. I just am not going to write it in. So what's my median here? 7. 7 is my middle number. So 7 is Q1. Okay, so Q1 is 7. And I'll circle. All right. After that, we need to find Q3. So Q3 is very similar. we're just going to find the median of the upper half of values in the data set, and that's also not including the second quartile, Q2. Yeah, so let's just draw the second half. We're not including 12, so we've got 15, 35, 41. So when we count in, our median is 35. So that's Q3. Okay. So we have officially found all of our values, all of them. So now we're going to look at step 6, which says to draw the box and whisker plot. So before we draw, let's make sure we understand how we're going to line it up. So I gave you a little guide right here. First, we start with a line up and down that lines up with whatever your minimum value is on this number line. What was our minimum value? 6. So that means my first point on my box plot needs to line up with this right here, with 6. So maybe before you draw your box plot, we could even go through and label our number line. So my minimum was 6. What was my maximum?
41.
41. So let's also label 41 right here. Okay, next let's go ahead and look where our median is going to be on this graph, where our Q2. So what's our Q2?
12.
12. So let's find 12 on here. I've got 10, 11, 12 right there. This is where Q2 goes. Now we just need to find Q1 and Q3. What was Q1?
7.
7. So I'm going to find 7 on the number line, which is right here. It's a little squished together, but that's all right. This is Q1. And where's Q3? Good. So we're going to go all the way over to 35 and make a mark there too. So now that we have everything labeled on our number line, we can start to draw the box and whisker plot. So we're going to go step by step, make sure that we're very careful with it. So I labeled what each point represents here. First, we draw that line up and down, and then we draw a whisker that connects to the box. The minimum value is where that end line lines up with, and the outer edge of the box is going to be where Q1 is. So we're going to have a very tiny whisker on this side, very tiny. I'm going to do something like this. Here's the outside, here's my whisker, here's my box. And it looks like my box stretches across all the way from Q1 over to Q3. You guys see that? So I'm going to draw a line that connects my box from Q1 at 7 all the way over to Q3 at 35, just like this. I'm going to have a very big box in this problem. I'm going to go ahead and draw the rest of the box. Just connect it, just like this. Okay, so we've got, if we want to check things off as we go, I did my minimum, I did Q1, I did Q3. Now if you notice there's a line in the middle here, that's going to be marking Q2 or our median. Where do I draw my line in this box?
12.
At 12. Good, I want it to line up about with 12. So here's my median or my Q2. And finally, I need to, I'll check that off, I need to draw one last whisker that stretches out to my maximum value. So where is my whisker going to stretch out to?
41.
41. So I'll draw it and then mark my point. That's it. That's a box and whisker plot, guys. We did it. Okay. And Tasha, I was thinking of you specifically from yesterday. I know you were
I was
saying,
hoping that she was thinking of me.
Yes.
Because that conversation.
does this help?
It did.
Good,
And
good,
I think
good,
my
good.
head may have been down yesterday. I would have maybe got it yesterday, so I,
All right, good deal. Yeah, absolutely. Okay, guys, any questions about a box and whisker plot? Any questions at all? Everybody feel okay about it?
Oh, yeah.
Good, 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 good. Yes, Erica.
Remember when I watched the video, you mentioned that you didn't know what this kind of graph was really useful for.
Yes.
It does illustrate outliers pretty well.
Outliers. Ooh, that is such a good point to make. So if we had a whisker that was super, 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 super long, we would know that whatever that other point on the outside was, it was probably an outlier or something that doesn't really fit with the data well. Good point, Erica. I appreciate that. I was curious about what we might use this for. Absolutely. Okay, guys. I'm going to keep track of time. It is 11:45. We still have about 10 minutes. In these 10 minutes, I want us to make a pretty big dent in this practice quiz. So, go ahead and pull out your practice quiz. We're going to go through as much as we can. So, on the first page, these questions are all worth 2 points each. All right? Those points are going to be based off of if you pick the correct answer, random or biased, and the other point is off of your explanation. You need to tell me why. So I'm not going to have you, no, just kidding. Let's just talk about these first, okay, since we've only got 10 minutes till lunch.
So we turn this in for grade.
No. This is just for you, for practice. So for number 1, it says, Tasha wants to know the most popular type of coffee that's being sold at mission grounds. So she asks everyone in algebra class what their favorite type of coffee is. Is that random or biased? Biased. Why?
Because she showed it in the algebra class.
Yeah. So she wants to know the most popular type of coffee that's being sold at mission grounds. Are the students in the algebra room the only people that go to mission grounds?
Not at all.
No. So it's biased because it does not include an equal opportunity for all of the customers to be chosen. We're only giving algebra kids an example or a chance to answer. Okay. Okay. Number 2. Chance wants to know how much sleep students at the Excel Center get each night on average, so he decides to ask 5 random people from each classroom every day this week to see how much they sleep each night. What is that? Random. Good. That's a really smart way to collect data.
All these questions you need to answer, we need to answer why.
Yes.
Yeah.
Need to tell me why.
So he asked people from every 5
Included every year.
Yeah.
Everybody had an equal opportunity.
Everybody had an equal chance of being chosen because he did it every single day of the week. So any student that would be here is going to be here at some point in that week unless there's an exception. He's asking 5 random people from each classroom. So that means every person that is here has an equal chance. Okay, let's look at number 3. Lily wants to know which favorite color is most popular among students at the Excel Center. So she decides to ask 5 students in the math room what their favorite colors are. Biased. Why?
So we asked 5 kids in the math room what they color was.
Right. She is wanting to know what the favorite color is from all the students at the Excel Center. The math room only is not going to be an accurate representation of that population. No way to know. Okay. We're going to move on to the next page. In 5, 4, 3, 2, 1. Okay. Second page, you're going to have 3 questions about correlation versus causation. Same thing, you're going to tell me which, you're going to tell me why. So, for number 4, I have the scenario as the rainfall increases, the amount of water in the rain collection bucket also increases. What is that? Causation. Absolutely. How do you know it's causation?
Because the rain caused the water to increase.
Yes, I would say rainfall causes water level to rise. It is a direct cause of that change. If the rainfall were to stop, that water is not going to keep getting higher. It doesn't work that way. Okay.
If it has some other influence at it.
Yes, unless there was an outside influence that we are unaware of. Absolutely. Okay, number 5, it says, as the amount of ice cream being sold increases, the amount of hot coffee being sold decreases.
That's a correlation,
It's a correlation.
because neither one of them affects the other.
Absolutely. Correlation only. I would say ice cream sales and coffee sales do not affect each other. Now, you could argue that in a very businessy way. Maybe there's some psychological factor going on with ice cream and coffee. Maybe there's shops by each other that seem to influence. We're not getting into that. We're just going with the reasoning here. If I sell more ice cream, that doesn't mean that the coffee place is going to sell less. It doesn't affect each other in that way. Ice cream increase does not cause coffee decrease.
Just put ice cream and coffee don't affect each other.
Yeah, you could also just say that. They don't affect each other. They don't affect each other. You could also say there is an outside influence that is affecting them both.
I said that there's no evidence to link the two.
Yeah, there you go. There's no evidence to link the two. That works too. Okay, number 6. This is a slightly trickier one because you could probably argue both. Miss Taylor notices that as she increases the amount of water she drinks each day, the frequency of her headaches decreases. Let's think about it.
That could be causative.
Yeah, because if you're drinking too much caffeine.
I'm gonna say this is causation. You guys are right. So obviously there are other variables to consider. Maybe the amount of sleep I'm getting, maybe exercise, maybe my diet. But if we are only looking at water, if I were to track data and check, when I'm drinking more water, my headaches are always going to be affected in a different way. It's going to decrease the amount of times I get a headache. If I stop drinking water, you bet I'm going to have a lot more headaches. So the amount of water I drink directly affects my headaches. It does. Yes, Chance?
I've got correlation because I figured that while the water provides stuff to the body that helps it fight it, so that's where it's going to be water. It doesn't fight it. If it's inflammation headache or something like that, it might be that prescription's not fixing it.
Right, right. So there are things to consider. You know, water isn't the only thing that could give somebody a headache, but we do need to ask ourselves for something to be considered causation. We could say, like for instance, I notice that when I increase the water I drink, my headaches get less, the frequency decreases. I need to ask, if I were to flip-flop this, would it affect it in an opposite way? You know, if I stopped drinking water, is that certainly going to give me another headache or give me more headaches? Even if there's outside influences, yes, any person, if you don't drink water, your head's going to hurt. If you don't drink water for long enough, it's the same thing as with the water in the plant. Plant having water's not the only thing affecting it. There's also sunlight, soil, other things. But if we change the water, it does also change the growth of the plant. It does change it. So it's not the only cause, but it is a cause. So number 6 would be causation. And I would say water intake directly affects headache frequency. Now, just because there's causation doesn't mean that it's the only cause. That's not what we're saying here. We're just saying that this does affect it. Water does affect headaches. Okay, questions about number 6? Okay, guys, it is lunchtime. It is lunchtime. So here is the deal. I'll leave this up for a second. The rest of the practice quiz we're going to finish after lunch. If you cannot be here for the second half, it will be posted on YouTube. You'll be able to get all of that.
What time do you think it'll be up?
It will be up. I always try to post it right when class ends. So I would say no later than 3 o'clock. That would be absolute latest is 3. But I'll shoot for like 1:30. 1:30. Yes, Erica?
I can't sign in to my class Gmail right now.
Oh.
Set it. Could I borrow?
Yes,
notebook
yes,
so I can
absolutely.
exit ticket?
Absolutely. Absolutely. And there's no exit ticket today since we're doing a quiz tomorrow. So if you're worried about missing today's exit ticket, you didn't. There's no exit ticket today. There might not be an exit ticket for the rest of the term, honestly, because there's only next week left. All right, I'm going to pause this recording. I didn't do that yet. Okay. All right, we are back from lunch. So let's look at page 3 of our practice quiz. Somebody read those directions for me, please.
Page 3, correct?
Yes, page 3.
All right. Draw the line that best fit for the data shown on the scatter plot below. Then answer the following questions about the data.
Perfect. Okay, so we need to draw the line of best fit here. So whenever we're drawing the line of best fit, remember it needs to be in the middle-ish of your data points. So if I were to draw it down here, would that be correct? If I drew it down here?
No.
No. What if I drew it up here? Would that be correct?
No.
No. How about right about here, somewhere in the middle? That look right? Yeah. Your line of best fit should be somewhere in the middle of your data. A good way to check and see if it's in the middle is to count some of the points and see if you've got about the same amount on either side of the line. Looks like over here I've got 1, 2, 3, 4, 5. This one's in the middle, so 6. Then over here I've got 1, 2, 3, 4, 5, 6, 7, 8. Ooh, I probably should have tilted it a little more this way, shouldn't I? Maybe I should thicken my line. Alright, so again, like I just showed you, obviously this isn't perfect. If your line looked like this and it wasn't the perfect amount of points on either side, I'm not going to count it wrong. We're just doing an estimate. So now that we've drawn our lines, go ahead and draw yours in. The next thing we'll do is write an equation in slope-intercept form, and I provided that for you. It's that y equals mx plus b. We want to use that to represent the data given on the scatter plot. So remember, whenever we are finding the equation of this line, we only want to use points that touch the line. So in my line that I drew, could I use this data point?
No.
No, why not?
It's not touching the line.
It's not touching the line. Could I use this data point?
Yes.
I could. This one is touching the line. So I'm going to go ahead and write out the coordinate for that. What would my coordinate be here?
3 and 85.
Yeah, we'd go over 3 on the x-axis, and it goes up 85% on the y-axis. So our first coordinate that I chose, you could choose different ones. I'll do 3 and 85. There we go. Good. And now we just need to pick one more coordinate. So if your line happens to go through 2 coordinates that are given, that's great. If not, you could pick a different one. So on my line, I see, looks like right here my line is touching a spot nicely. So maybe I could do the coordinate 1 and 75. You could also look at your y-intercept, skip a step maybe. That way you wouldn't have to solve for b, you just have it right here. It looks like my y-intercept is somewhere between 65 and 70, but close enough to 70 that I'm going to estimate it's 0, 70. You could do this forever. You could come up with a million different coordinates. But for the point or the purpose of this activity, number 7, we're trying to write the equation of the line. So before we pick our coordinates that we're going to use, let's talk about what our steps are to writing a line. There's 3 steps, guys. Can somebody remind me what those 3 steps are?
Find M.
Yep, find M or your slope. Yep, find y-intercept or your b. Yep, and then step 3 is just write the equation. Not too bad. We did this last unit. So, which coordinates are you guys going to use? Somebody want to throw one out me so we can... 0, 70. Okay, we'll use this one. What other coordinate would you like to use? 3 and 85. Yeah, let's do that. Okay, so I'm going to bring those coordinates out over here where I've got a little more space to work, just so that I'm not making a big mess. So I chose the coordinates 0, 70, and 3, 85. So I need to find my slope first. Before I do that, this is just a good habit to be in. I'm going to label my coordinate, my x's and my y's. It's nice to keep track of everything. It's the silliest little mistake you can make is accidentally switching your x's and your y's up. That'll mess up your whole answer. Okay. Now, this would be a great thing to write on your practice quiz since you can use it on the quiz. What's our slope formula?
M equals
85,
70, 1/5, that's the rise.
Here, first I'm going to write where my x's and y's go. I'm going to do it a little bit more slowly, but Star, you're completely correct. Absolutely. I want to just have this format filled out just in case. What is being subtracted on top? My y's or my x's? Y's. Good. So y2 minus y1, or like what Star said, my y2 is 85, my y1 is 70. So 85 minus 70 over x2 minus x1, and what are those values?
That is 3 and 0.
Good. Over 3 minus 0. Okay. And let's solve that real quick. Let's see what we get. 85 minus 70. I got 15 over 3. What did you guys get?
15 over 3.
Okay, perfect. 15 over 3. Can we simplify?
Yeah.
We sure can, guys. If I divide both of them by 3, 5 over 1, which whenever we're solving for b, if we needed to, I would just keep it as 5. So there's less mistakes that are possible to be made with fractions. Our slope is 5. Okay, so I'm going to take my slope and I'm going to write it over here. I gave you a spot where I want you to put your answer for slope. So I would put 5 in this case. Okay, now what's our b?
We have to do the equation.
70.
Yes, so there's two things we could do here. Number one, we were able to find our y-intercept visually. We know that it's going to be 70. But just in case, let's go through the process of how we would find it if we don't remember that tomorrow. Or if we don't have a b that's as obvious as that one. So which coordinate do you guys want to work with?
0, 7.
Yeah, let's work with 0, 70. All right. All right. So we are going to plug that into y equals 5x, because that's our m, plus b. So our y is 70 equals 5 times our x, which is 0, plus b. And what's 5 times 0?
0.
0. So we're just going to cross it off and say 70 is b. So once you find your b, please write it in the spot I gave you. Yes? Sounds good. Me too, man. Me too. All right. So we have our m and our b. How do we write the equation? What are we thinking?
Equals 5x plus 70.
Absolutely. Y equals 5x plus 70. That's your answer, guys. Any questions on that? We feel okay about it? Good, 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 good. Okay, let's move on to number 8. It says, based on your estimation of the line of best fit, so based on that equation we found, how many hours would Jasmine need to spend studying to score about 90% on the test? How would we solve this?
Well, since the since our y all we have to solve for is x. So we can set up the equation and replace the y with that 90%.
Awesome. Okay, so we can look at which variable represents each item. We know that the hours are on the x-axis. The test scores are on the y-axis. So she wants a 90%, so we can plug 90 into our equation that we found. We have a y and we have an x. So I'll rewrite that. Y equals 5x plus 70. Okay, and then we're going to put 90 in for y, guys. Is anybody confused about why we're putting 90 in the y spot instead of the x? Okay, good. All right. So what variable are we solving for?
X.
X. All right, how are we going to do that?
Subtract 70 from both sides.
Subtract 70. All right. Okay, let me move this camera down so y'all can see a little better. Running out of space. Okay, what happens to my 70s?
Cancel.
They cancel. And I'm going to rewrite this over here. I've got 90 minus 70, which is 20, equals 5x. All right, what do I have left to do? Divide. Good. So we're going to divide by 5 on both sides.
4.
Yep. And we're going to get 20 divided by 5 is 4 equals x. So we know that x is 4. What does that mean?
4 hours.
Yes. That's going to answer our question here, which is how many hours would Jasmine need to spend studying to get a 90%? According to our data, she would need to study about 4 hours. So I want you to write that answer, not in just x equals 4. We need to answer how many hours she needs to spend studying. So I would say Jasmine would need to study for 4 hours.
What if we
Per-
just put 4 hours?
I'm not going to count you wrong if you just write 4 hours, but I feel like the most proper answer would be one that's in a sentence.
Okay.
That's always going to be a little more clear to me.
Okay.
In this case, if you just said 4 hours, that's fine. That's fine.
Or Jamie.
Yes, or Jamie. All right, any questions on that process? We feel okay about it, guys? Good. Okay, let's go to page 4. Here's where we start looking at bar graphs.
Yay.
I'm not making you draw one. We're just going to make sure we can interpret a bar graph. So each of these questions is worth 1 point each. They're fairly simple questions. I have given you a bar graph of candy flavor preference by gender. So you can see that we have female flavors in purple, male flavors in blue. All of the flavors are labeled below, and the count is on this side to tell us how many males or females said they preferred which flavor. Okay. So let's look at our questions here. Number 9, true or false? Females voted for blueberry less than males.
False.
Oh, false. Yeah, let's look. So it says females voted for blueberry. Let's look at blueberry. Okay, there's females right here. And now we're comparing it to males. There's the male blueberry votes. And females definitely voted more. Looks like 15 said blueberry. and for males, only 10 said blueberry. So you guys are right. Females voted for blueberry less than males. That is false. You can just circle your answer for that one. Okay, let's look at number 10. Which flavor is most preferred by males according to the bar graph?
Cherry.
Cherry, good. That one's easy. We can just look and see which blue bar is the highest. And in this case, cherry is the highest blue bar. So you could just say cherry. All right, number 11, which flavor is least preferred by females?
Cherry.
Also cherry. We're looking at the smallest purple bar, and in this case, it's cherry. So again, we'll just write cherry. And last but not least, number 12 here, how many more females prefer raspberry flavored candy over blueberry flavored candy? So I'm looking for a difference. Oh man, you guys are on it. Okay, so raspberry versus blueberry. Let's find that. And we're talking about females. So raspberry, there's 30, and blueberry, there's 15. So all you would need to do to find the difference is see how much goes from here to here, which is 15. You could also do 30 minus 15 to get that answer. So I would say for number 12, how many more females? We can just say 15. I'm fine with you just giving me a number. All right. Any questions about page 4? All right, let's try 5. We're almost to the end, guys. These questions are all referencing this histogram. It's a histogram of birthdays. So each bar represents a month, and the frequency is telling us how many people's birthdays fall within that month. So it looks like we've got a lot of months in January, or a lot of people with birthdays in January, a few in February, a little more in March, and so on and so forth. So let's look at our questions. Number 13 says, which month has the most birthdays? January. Simple answer. You can just write January. Which month has the least birthdays? February. That's right. February's only got 2. All right. February. February's the weirdest month to spell, in my opinion. I feel like I don't say it right in real life. How do you guys say that?
February.
You just say February? I guess it's actually February. February. Ugh.
It's like Japanese.
I guess so. I guess so.
February.
What's up, Erica?
It looks like we have half a birthday.
In October, let's see.
It's a little bit tall for a 3.
1.
Yeah, it's supposed to be a 3, but I guess I drew it a little tall. This is where the error of my art comes through. It's okay. It's not perfect. I'm not an artiste. I did my best though. So yes, there is, I guess, a half person in October, and or I made the line a little too thick. That's all right. I appreciate you looking at that though. It wasn't meant to be a half person. Okay, let's look at 15. How many more birthdays are there in November than in October? Now, obviously October is the one that is a little questionable. If you are taking the quiz tomorrow and there's a case like this where you're not sure if it's supposed to be a 3, you can ask me and I'll clarify for you. I don't want you to feel like you gotta guess because my art skills aren't great. You can ask. So for this question, we'll say October's got 3 birthdays. How many birthdays are in November? 10. Good. So now we know that. How many more birthdays are there in November than October? 7 or 8? 7. 3 plus 7 makes 10. Good. There's 7 away from there. You could also do 10 minus 3, and that would give you 7. So how many more birthdays are there in November than October? 7. All right, last page. Here we go. Crazy. You guys believe it? We're almost done with Unit 2. What the heck? Okay. You're going to construct a box and whisker plot with this data. So if you need to go back and reference that guide I gave you today, we're just going to follow these 5 steps here, okay? So step 1. Somebody tell me what I need to do first. Put the numbers in order. All right, let's do that. So I'm going to look through and find my smallest number first. 42 looks like the smallest, so I'm going to write 42. And then next I've got a 46. I've also got a 44. Yep, let's do that one next. 44, 46. Then next I've got probably, 51, 58, 60, yep, 67, 69, 72. 67, 69, 72. Okay, there's our ordered numbers. So, what's our next step once our numbers are in order?
Put the lines on the sides and then get the minimum and maximum.
Yeah, let's go ahead and find our minimum value and our maximum value. And once we find those, we can go ahead and fill in our answers. What's our minimum value? 42. So I'm going to write 42 in the minimum spot. What's my max? 72. So I'll write 72 in the maximum spot. Okay, all that's left to do now before we draw the box and whisker plot, is to find our Q1, Q2, and Q3. How do we do that? Which one should we do first? Does it matter?
Let's go Q2.
Yeah, we want to always try to do Q2 first, because our Q2 might affect our Q1 and Q3 answers, because once we find Q2, that is going to not be included when we're finding the median of the lower half and the upper half. So like in this problem here, when we found that 12 was our middle number, when we found the median of the rest of the data for Q1 and Q3, we did not include 12 as a number. We did not include 12. So let's make sure that we do Q2 first. All right, what is our median here? Do you guys know? Let's check. I bet you're right. Okay, I got 44 and 69. I've got 46 and 67. I've got 51 and 60. And then 58's in the middle. There we go. Nice. So Q2 is 58. Good. All right. What is Q1? How are we going to find that? Yeah, we got to look at our top half, or sorry, our lower half of data, the smaller numbers. So we're going to look, not including this, not including Q2. I've got 42 and 51, 44 and 46. What number's in between 44 and 46? Yep, 45. Awesome. All right, now let's do Q3. Same process. Don't include 58. We've got 60 and 72, 67 and 69. What's in between those? 68. Not so bad, guys. Good, good, good. Okay, now, here's where I would be a little careful, making sure that we get our box plot accurate, our box and whisker plot accurate, what I would like you to do, and I'm not going to take points off if you don't, but I'm going to say that it will be helpful for you, is plotting your points on your number line before you draw. I think that's going to help you. So I'm going to start with my minimum, and that's 42. So I've got 40, 41, 42. I'm going to draw a point there and just label it minimum. And then my maximum is 72. So I'll find 70, 71, 72 right here. There's my max. All right. Now I'll do my Q1, Q2, Q3. What's my Q1?
45.
45. So I've got 40 and 50. Right in between them is 45. Okay. My Q3 is 68. So here's 60, 65, 66, 67, 68. Right here. And now we can label our median, or our Q2, which is 58. So there's 55, 56, 57, 58 right there. All right. There we go. So now that we have our points plotted, all we have to do is make the drawing of the box and whisker plot just like this. You're going to want your whisker to line up with your minimum. Your edge of the box is going to line up with Q1 and Q3. Those are your two edges. Q2 is just a line that we use to separate the box in the middle. And your other whisker is going to line up with the max. So I'm going to go ahead and draw this, and you guys should draw it too. Make sure that yours looks like mine. Make sure we feel good about why we're doing it a certain way. So there's my minimum. Draw my whisker. And I stop once I get to the next point, which is Q1. Now I draw the outside of my box. And I actually like to draw these three lines before kind of connecting my box. I've got my Q1, my median, there's my line in the middle, my Q3, that's the other edge of my box. And here is my last whisker. So now I turn my paper to the side because I just am better at drawing lines like this. I'm going to do that. Okay, there it is. That's my box and whisker plot. And it looks like this data is distributed pretty evenly here. Pretty even spread. All right, do we have any questions, guys? That's it. That's it for today. I'm not giving you an exit ticket. Just go over your notes, go over your practice quiz. If you missed any lessons, go back and watch them. We have a quiz tomorrow. All right, Unit 2 quiz tomorrow. So you can use any of your notes on it. You can use this practice quiz. If you have questions before then, let me know. Send me an email. Send me a message on Google Classroom. I'm happy to answer any way I can. So I will see y'all later.